Okay, so good morning, everyone. I think it's a good morning in India also. So let me start the topic neural network and backpropagation. And here in this 1 hour talk, I will explain you the basic concept of neural network, means how neural network work and how different layers are connected, how we can apply backpropagation and all those things. What is forward propagation, what is backpropagation, and we'll try to understand this neural network with the help of few examples, right? And if we'll get time, then we'll go through the code of this neural network quickly, right? So here, like, first of all, I will start with the biological inspiration behind ANN, because whatever like artificial neural network we are going to use, there is a biological inspiration. Biological inspiration means like ANN is motivated with our brain neurons. So we'll discuss about that. Then a single layer perceptron and multi-layer perceptron we are going to discuss. So first start with the application of neural network. This neural network can be used in different application areas. In front of you, there are few like aerospace, space, mechanics, electronics, manufacturing, robotics, and many more. Right? These are just only a few numbers, but it is spread in vast application areas. We can use this neural network in so many things. And one more important point is neural network is the base of almost all the deep learning techniques, right? So whatever CNN or other technique, generative adversarial network or other techniques like you are going to use, somehow they are going to use neural network, right? So it's a base of all deep learning techniques. So we should be aware about this neural network concept if you want to explore yourself. Okay, so as I told you, like, we will discuss about the fundamentals of biological underpinning of neural network. So as we can see, like in our brain, there are neurons. The neurons are in millions and billions in number, right? And these neurons are connected with each other. And using this connection, they process the information and they take decision. So like, for example, I'm talking now, right? So I'm talking on the basis of my processing. Some processing is going on in my mind, and my mind using that processing, my mind tells like I need to give talk on neural network today, right? So lots of neurons, means millions of neurons are working behind that. So the neural network is inspired from the same thing, means we can say neural network is inspired from human brain neuron. And likewise, like neurons are connected with each other, they take decision in the same way. In neural network also there are neurons, right? And these neurons are connected with each other and they take decisions. So we'll understand that thing in detail now. So if you discuss about this brain neuron structure, then like there are different like parts of a brain. Like we are not a medical student or we are not a medical professional, so no need to go in the deep, just but like we need to understand few parts, like how our brain works. So there are different parts like cell body, dendrites, nucleus, axon, synapse, right? So they have like different functionality. If you're talking for cell body, then cell body is for processing information. Dendrites and axons are to connect like one neuron to another neuron. Like same way, synapse represents like last terminal neuron and like that, right? So we have different body parts, and these body parts are connected with each other. Using these connections, our brain takes a decision, right? So similar kinds of concept we are going to use like in neural network. So if we'll talk about dendrite, then they receive signal from other neurons that get connected to it. Means they receive signal from another neuron, like we are going to connect. So just if you want to see dendrite, then we can go back. So here, like dendrite, right? This is dendrite. Cell body information processing happen in a cell body. They take in all the information coming from different dendrite and process that information, right? So here, like from dendrite, they takes information and process that one. And then axon means it sends the output signal to another neuron for the flow of information. So this is an axon. Like output of this one neuron will be like transferred to another neuron using this axon. So like there are different body parts are there, different brain parts are there, and using that, like we take decision and we give output. So by inspired from like this brain neuron structure, we have artificial neural network. That's also called some like there's also called a neural network. So in artificial neural network, what we have like input layer, hidden layers, and output layer. If you're talking for input layer means just we are giving input. For example, at this moment, like mail from Priyanka madam told like I need to like give talk on neural network, right? This is input, right? So now we have given input. Then after taking input, then we need to process that information. So the processing happens in like different hidden layers, right? Different hidden layers. So we have layers and like we do processing. Now we have only two hidden layers here, but it is always not mandatory to have two layers. It can have only one layer. It can have more than two layers also. It depends on the task, like what kinds of task we have. Accordingly, like we are assigned with number of layers, right? We assign like different number of layers, right? So for example, if you're talking for input here, now, in this input, let's talk about any data set, real data set, based on just text information or based on CSV file, right? In data set is in CSV file. Like we are talking, there are so many data set. Like one is a Titanic data set. So in Titanic data set, we have different columns. So these columns are called features, right? So for example, there are four features, four input columns are there in that particular data set. So if I can recall, there are one column is SIVSP, another is PARCH, right? Number of people and tickets, right? In that particular data set. So let's say we are not writing a particular real number, just we are writing any tentative number like X1, this is X2, right? This is X3 and X4. Right, we have four features. That means four columns in four input columns in that particular data set. So these for each input column, we will make one input neuron. In this is also we can also like say it's a neuron, but exactly like neuron will be hidden layer. So we are making one neuron point for each of that input for X1, X2, X3, X4. If like there are 10 inputs, then we need to make 10, right? 10 neurons. Right, so depend on our data set. Now, once we have this X1, X2, X3, X4, then we need to work for like hidden layer. Now, if you're talking about first hidden layer, in a first hidden layer, we have like neurons. So we have 5 neurons here, right? 5 neurons here. It is not fixed like we should have only 5 neurons. It can have less than 5, it can have more than 5. Depends on application, depends on like particular data set. So in this example, we have 5. So what will happen with these 5 neurons? Like this, each of the particular input feature will be connected with these 5 neurons. So it's a fully connected network, right? So like here, like all these, right? 5. It should be connected with 5, right? One more connection should be there, and likewise here, here, like that. So we will have like different connections, and this connection will represent with particular weight. Like for example, W0, W1, W3, W2, like that. Okay, so we have different weights. These are the variables, so you can write any of the names. Some person refer it theta, some person refer it W, and like that. Okay, so you can write any of the name as per your requirement. So we have all these W0 to like let's say WN, right? Now once we have these weights, and the value of these weights will be assigned randomly in the beginning, right? Whatever these weights are there, just any random value will take in the beginning for these weights, like anything, like W0 equal to 2, W1 equal to 5, W2 equal to 10, like that, okay? Even in decimal also you can take. So we'll assign the random value for all W0 to Wn. Now, likewise, will have another hidden layer, right? And a same weights connections. And again, like we can assign value of W for this one. Randomly, we can assign the value. Now, we have one hidden layer, another hidden layer. In case, for example, sometimes our model is highly complex. Our model is highly complex. Our data set is highly complex, means there are lots of noise in our data set, and there are so many problems in our data set. Then, in those cases, like those two layers will not be sufficient. Then we should go for more than two layers. So, like more than two hidden layers. Then we can have like another hidden layer, another hidden layer, another hidden layer, and there are neurons in these hidden layers, and all these neurons will be connected with each other, right? So this is the way like we can make this like these hidden layers. Then finally, whatever will be the last hidden layer, that last hidden layer will be connected with the output layer, right? Output layer. So now, if you're talking for output layer, the output layer is a specific one. Because here in hidden layers, we can have any number of neurons based on the complexity of data set. Like if you're taking 5 neurons, that's okay. If you're taking 6 or 7 neurons, that is also okay. If you're taking 3 neurons, that is also okay, right? But if you're talking for output layer, then in output layer, like neurons will be fixed. It will be completely depend on your data set. Data set means specifically your output column, right? If you're talking about any of the data set, then there are inputs and one last column, or like anywhere like there's a label output column. So the number of neurons in output layer depends on your label, right? On your output column. If your label is binary, binary means it's a classification label and it's a binary classification. Binary classification means only there are two classes, right? For example, we can talk about like any disease prediction, like cancer prediction. So there are two types of classes, just malignant or benign, right? So only two, binary, 0 or 1, true, false, or malignant, blind, like that, whatever you tell. So we have two classes, binary classification. If you have binary classification, then in case of binary classification, we will have only one neuron in output layer, only one neuron in output layer, right? So this is fixed, we can't change it. And now, if like we have one neuron in output layer, in this case, we apply the sigmoid activation function. Here, we apply the sigmoid activation function. So what sigmoid activation function do? It's like just S-shaped curve, right? S-shaped curve, and on center we have value 0.5, and here we have class 1, here we have class 0, right? So using this neuron will get particular value, and if this value is greater than 0.5, then we will consider as class 1. If this value is less than 0.5, we'll consider as a class 0, right? So in this case, we can do binary classification. But if we have multi-class classification, means our classes are more than 2, then what will happen? If classes are more than 2, then what will happen? Like this. Then we will have number of neurons equivalent to the number of classes. Like for example, there are 4 classes, right? There are 4 classes in our data set. Then we'll have 4 neurons, 1, 2, 3, 4 neurons. And in this case, we apply the softmax activation function, right? In the last layer, we apply the softmax activation function. What softmax activation function do? It generates the probability corresponding to each of the class. Like for example, this class, for this class, it will generate the probability, but our output will be corresponding to the highest probability, right? For example, we are doing vehicle classification. There are 4 types of vehicles in our data set: car, truck, bike, or bicycle. Then if in case like we have features of car, then for car we'll get highest probability, and for other we'll get lower probability than that highest one. Then we can say like in output we have a car. So this is the basic mechanism behind this like neural network. And one more thing we can do here, like we got this neuron, right? So for these neurons we need to get value. So how to get this value? This value will be equivalent to like x1 multiplied by w0 plus another, like let's say w1. So x2 multiplied by w1 plus x3 multiplied by w3 plus x4 multiplied by w4, like that. Okay, so for each neuron, we get like similar kinds of value. Like similarly, we'll calculate this value. Now, if we are applying this in this way, x0 w0, x1 w0 plus x2 w1 plus x3 w2, like that, then it's a kind of linear classification. It's a kind of linear classification. So you know, like in real, if you're talking about real life, and in real life, like most of the things are non-linear, right? Non-linear. Linear, just you can understand linear with a simple example. For example, you are coming to your university from your home. Then if you are taking same path, like you are not turning left, right, or somewhere, that's called linear, right? But in most of the cases, your school or your university is far away from your home, right? So you have to take turn, right? So that's called non-linear. So most of the things in real world are non-linear. So in this case, if things are non-linear, then this linearity will not work effectively. So what we need to do? We need to apply some activation function on this one. So after calculating all these neurons, we need to apply activation function. So there are so many different activation functions are there. Like a ReLU activation function, ELU, and other different, right? Hyperbolic. But like mostly like we use ReLU activation function for bringing the non-linearity in this one. So we apply activation function and we get the output. So this is the way, like we can calculate this, we can compute, we can use this artificial neural network. So this was the basic of this artificial neural network. Now we will move I will explain you with the help of example also, like how we can use this artificial neural network. So if you're talking for ANN structure, I already like discuss everything. Like the network start with the input layer that receive input in the data form. The lines connected to the hidden layers are called weights, and they add up on the hidden layer, right? Each dot in the hidden layer processes the input and it puts a output into the next hidden layer and lastly into the output layer, like that. Okay, so we have discussed each dot means each neurons process the input and it passes to the output. It passes to the next layer. It passes to the next layer and we can get the output. This is the way we can work on ANN, right? Now, as I mentioned a few minutes back, like ANN is the base for like most of the deep learning models. So let's have just one slide related to deep learning. And deep learning comes under the realm of machine learning. It's a sub part of machine learning, which imitates the working of human brain with the help of artificial neural network. Popular in processing big data and can generate valuable insight into important decision. Valuable insight means we can extract features also with the help of deep learning techniques. In case of this simple normal neural network, we need to assign features, right? We need to give features from manually from the data set. But if you are applying deep learning, then automatically like our CNN layer can extract features. So there's a variety of frameworks developed around deep learning, like using TensorFlow, Keras, PyTorch, and like that. And these frameworks allow easy integration for machine learning and AI functionality, right? Like that, we can do this one. So if you see the same architecture in a different format, like previous architecture, previous artificial neural network architecture. So here, like we have like inputs, like x1 to xn, as I mentioned you earlier. And we have one output layer. So we are discussing about very simple neural network in which we have input layer and just we have output layer. We don't have any hidden layer. This is also a single layer perceptron. So we have like inputs and output. Then these inputs will be connected with the output using these weights, right? W1 to Wn. We have W1, W2, W3, Wn. And now if we'll calculate the sum, right? We'll calculate the sum. Then this sum will be equivalent to first of all, we will calculate sum, and this sum will be equivalent to x1 multiplied by w1 plus x2 multiplied by w2, x3 multiplied by w3, like that. So xi, wi we are going to do, and I equal to 1 to n. So here n is equal to n, right? This one, 1, 2, 3, and this up to n we are going to do. Then after applying this sum function, we need to apply activation, right? As I told you, we don't want linear things, linear output. So for being non-linearity, we are going to apply activation function. So there are so many activation functions, and here we'll use step activation function to make our calculation easy. So like we have this one, and just we expanded this part here, x1 w1, x2 w2, x3 w3. Now here we are going to take one example, like we are going to understand a single layer perceptron, and this single layer perceptron we are going to understand with the help of one simple example, in which like there are two inputs. One is age and year of experience. On the basis of age and year of experience, we are deciding whether the person qualify for job or not, right? So yes or no. This is a binary classification. So we need to get either qualify or not qualify. So for example, like our inputs are like age 45 years old, the years of experience 25 years. Then we are assigning weights 0.7, 0.1. As I told you, we need to assign these weights randomly, right? So any of the value we have taken 0.7, 0.1. Now, if we'll calculate it, then we'll get 45 multiplied by 0.7, right? Plus 25 multiplied by 0.1, 0.1, right? So if we calculate this thing, then we'll get some 34. So we got this value 34, right? Some value we got 34. Now, once we got sum, then on sum we are going to apply step activation function, right? Step function. So the what step function do? If return value from sum is greater or equal to 1, then output will be 1, otherwise output will be 0. So if the return value, like whatever 34 we received here, right? If the 34, like this value is greater than or equal to 1, then output will be 1, otherwise it will be 0. So in this case, we return 34. Obviously, it is greater than 1. So our output will be 1, right? Because we return 34, right? So in this case, we can say our output is 1. That means if person has 45 years age, if person is 45 years old, and year of experience is 25 years, then he qualifies for that particular job, right? Yes. Now let's understand the same perceptron with different example. Different example means a little bit like we are going to change the value of weights. So here I would like to show you the importance of weight here, right? Why we are assigning these weights, and like why we are going to learn these weights, why we are going to find proper weights. Using this example, you will understand this thing. Now, for example, like we are taking, we change these weights. Like for example, earlier it was for 0.7, 0.1. Then we we told like our step function is 1. In this case, like for example, we are assigning 0.7. That means we are giving more weight to age and less weight to experience. 0.1 to 25 means we are giving more weight. Means if person is old, then we need to like give preference to that particular person, right? So the 0.7 weight for like age, and just we are not taking care of experience, right? For example, we are hiring someone for like cleaning job, right? So cleaning, just a person is old, then they will not leave a job, and we don't require much experience. Like cleaning is a very simple task anyone can do, right? So just 0.1 we are focusing, right? Now take another scenario. Like for example, we want to assign minus 0.7 weight to age. Means we are not taking care about age at all. We are focusing on experience. We can change this value, like we can do 0.5, 0.6 also. So we are focusing more on experience as compared to age. So if we'll do this, then same calculation, 45 multiplied by 0.7, 25 multiplied by 0.1, right? So once we'll do this, and we'll get output minus 29. We are getting minus 29. Again, we will apply the step function because this value is less than 1. That's why it will be 0. So output will be 0. So output is 0. That means output is 0. That means the person doesn't qualify for this job, right? So what do you understand from this example? Like we understand this, weights have a very important role in neural network, right? Using these weights, our output can be changed. Our output can be positive, our output can be negative using these weights value, right? So that's why we should select, we should choose this weights value very carefully, otherwise we'll not get proper output, right? So now if you're talking for neural network, then as I told you in the beginning, we assign these weights randomly. We assign any value of these weights, right? We randomly assign this value of these weights, but we need to train these weights. We need to find the proper output. We need to find the final output using these weights. We need to find the final proper output of these weights. So that we do with the help of forward propagation and back propagation. So this thing is called forward propagation. Like we did like 45 multiplied by 0.7 plus 25 multiplied by 0.1, we got output, right? And we got output 0. This is called forward propagation. Means we are going from left to right, right? And we are calculating. It's called forward propagation, right? And in the next step, we'll understand the back propagation, but here also you can understand this thing. Like for example, we got this, we assigned these weights 0.7 and other things, we got 0. In case we have actual output also. If you talk about real data set, if you talk about data set, in data set, like for example, there are 3 inputs, 1, 2, and 3, and 1 output, right? 3 inputs and 1 output. So now in data set, we have 3 inputs and corresponding to that we have output. Corresponding to that we have output. So we have actual output, right? We know the true output. So what will happen? We applied 3 inputs. We got particular output. We got this particular output, let's say this 0. And we are assuming that this 0 output is not correct in the beginning because we are randomly assigned these weights, right? So what we need to do? We need to update these weights, right? We need to update these weights because we want the correct output. So for updating, for the updation process purpose, we apply the back propagation. So back propagation we do from right to left. Means whatever output we are getting, on the basis of that we can calculate loss function, means how much loss is there, and according to that loss function we change these weights value, right? We update these weights value, then again we apply the forward propagation, right? So this one cycle from input to output and output to input is called one epoch, right? This is called one epoch. So we'll discuss this thing in a very detail later on. So let's start with this. Let's start the single layer perceptron. Let's understand the single layer perceptron with one example of AND gate. And I think all of you are familiar with the AND gate. There are 2 inputs, X1 and X2, and our output will be true only when we have true. Both inputs are true, right? Then only our output will be true. So we can write in this way also, like 0, 0, 0, like that. So once we have both inputs are true, then only our output will be true, otherwise it will be false. So we need to implement this AND gate with the help of this single layer perceptron. So how we are going to do this? So for example, we have 2 inputs, X1 and X2, and now we have 2 inputs, 0, 0, 0, 1, 1, 0, 1, 1, right? So 2 inputs X1 and X2, and values are 0, 0, 0, 1, 1, 0, 1, 1. So what we'll do, we are taking inputs 0, 0, right? Then 1, 0, and 0, 1, and 1, 1. So same perceptron, but different inputs. once we have assigned 0, 0, in the beginning just we are taking 0, 0 value, right? Random value we are taking, just random 0, 0 value we are going to take. And what we do is multiply 0 multiply by 0 plus 0 multiply by 0, we are getting 0, right? And the same way 1 multiply by 0 plus 0 multiply by 0, like that we are getting, right? We are getting all these things. And if we are getting 0, here also we are getting 0, here also we are getting 0. In this case, we are not yeah. So here, like once we are getting 0, 0, 0, so if we see our error, our predicted outputs are 0, 0, 0 in all cases, right? But our actual outputs are like here, like we have 1. So if we calculate error, then there is no error, no error, no error. But in this case, we have error, right? Because our actual output was 1, but we got 0, so 1. So out of 4, we got error in 1. So 3 by 4 we got. So we can select 75% accuracy is there, because out of 4, 3 are correct, but 1 is not correct. 75% accuracy is there. So now, next step, what we need to do? We need to update these weights, right? So this updating procedure is called back propagation. This is called forward propagation, right? Whatever calculation we did, this is called forward propagation. Now we need to apply back propagation. So for back propagation purpose, what we need to do? Well, like we need to find the change in the weight, right? We need to find the updated weight. So updated weight equal to weight n plus 1 equal to, we are doing weight n, right? Plus learning rate multiply by input multiply by error, right? So weight n is the old weight, like in this case we have 0 and 0. Learning rate, so this learning rate is one of the important concept. So learning rate here means, just quickly I can go through, I will not go in the deep of that one. So learning rate, if you have high learning rate, so learning rate high means like our weights will be changed drastically, means there will be a huge change in weight value. Like for example, this is 0. If learning rate is high, then maybe like it can become, it can be like 10. After 0, it can be a 10, all right, or 20. Like suddenly, like it will change. If your learning rate 0, if learning rate's low, then that means it will change slowly. Like for example, 0, then next will be 0 0.1 or 0 0.01, like that. Depends. So learning rate, then multiply by input. So input value like 0, or here we have 1. Then multiply by error. So we'll take error term from here, right? So just keep this formula in your mind, and we need to apply back propagation. So we have this formula Wn plus 1 equal to Wn plus learning rate, input, and error. Now we are going to calculate Wn plus 1. It will be equivalent to like weight n, which is 0. And one more important point, for all the inputs, we need to take equal weight. We can't change it. 0, 0 is there, then in all cases, we will have 0, 0. We can't change it. Now, in this case, we are getting error, like in this example, we are getting error here only, right? We are getting error here only, because our actual output was 1, but we got 0. So error is in this case, but in all other 3 cases, we are getting correct output. So whenever we are getting error, we'll focus on that part only. So we are getting error here for input 1, 1. So 1, 1, 0, 0, like was our old weights. 0, 0 was were our old weights. Then in this case, we are getting 0, but our actual output should be 1. So what we will do, we'll need to update these weights. So for updating purpose, what we are doing, weight n plus 1 equal to weight n, learning rate, input, and error. So weight n plus 1 we are writing. Weight n is 0, right? Because our input is 0. At this moment, we are talking about this part only, right? This part. Weight n equal to 0. Learning rate 0.1 we assigned, right? And input is 1. This input is 1. And error is 1. Our error is 1 here. Error is 1. Right? So error is 1. So once we did this, if we calculate, we'll get Wn plus 1 equal 0.1. So our next weight will be 0.1. In place of 0, we write 0.1. Likewise, we can update this part also, right? This one. So we have similar value, like weight n plus 1 equal to weight n, learning rate, input, and error. So weight n equal to 0, learning rate 0.1, right? We have 0.1 and input 1, error is 1, and we are getting 0.1. So this will get 0.1. This is the way like we can update this one. So we got 0.1 and 0.1 same. Now we'll repeat the same thing with 0.1 weight, but at this time we will apply for all the inputs. It is not the case like we will apply only on that selected input. We need to apply for all the inputs again, right? Because we should have same weight for all the inputs. So 0, 0, again 0.1, 0.1, we are applying, 0.1, 0.1, we are applying, and we'll get output 0, 0.1, 0.1, 0.2, right? So in this case, like if you'll apply step function, right? We are applying step function. So all values are less than 1. All values are less than 1. If these values are less than 1, then again, our predicted output will be 0, 0, 0, right? And again, the same error we are going to get in the last one, right? So what we need to do, again, we need to repeat the same thing, right? We need to apply this thing. So in this at this time, like our weight n is 0.1, like if you're talking for this part, right? Weight n is 0.1, learning rate 0.1. Learning rate we keep like same in most of the cases, but we update also, but we are not going to discuss that thing at this moment. But we are keeping learning rate 0.1 at this moment. Input is 1, error is 1, right? So we got 0.2. So we change this weight to 0.2. Then again, similarly, we change this weight to 0.2 using this part. So we got this thing, right? 0.2, 0.2 be assigned. And again, we repeat the same thing. And we repeat the same thing. And we assign the 0.2 and we'll get the output. So in this case, like for 0.2 case also, we'll get the error. Same output we'll get, 0, 0, just likewise. We'll get the same output using 0.2. Right, we'll get the same predicted output. So we are getting error. So now I'm going to skip many steps here, right? And I'm going to move. I'm directly jumping on the final step. We'll update this so many times, right? And finally we'll get the output, correct output on these weights, right? We'll update. This is 0.5. Please ignore this one. 0.5. So we'll get our final output on 0.5. Correct output. So 0.5, 0.5, 0.5, like that, all this thing will do. So 0 multiplied by 0.5 plus 0 multiplied by 0.5, 1 multiplied 0.5, 0 multiplied 0.5, like that will do. And in this case, we are going to get 1, right? And all the other case will get 0 because these values are less than 1. If you will apply a step function, if value is less than 1, then 0. If value is greater than equal to 1, then it's 1. And it will be 1. So in this case, we are getting predicted output 0, 0, 0, 1. That is equivalent to our output class. So now we can say there is no error. We are getting 100% accuracy. So this is the basic mechanism behind this forward propagation and back propagation. The target of back propagation is to get final weights. And once we are getting final weights, then we can say our model is trained. Our model is trained, right? Like we talk about the things like we need to train our model and other things. What is the actual meaning of training? The actual meaning of training is to find final parameter values, right? And these parameters values we can use in another model also, another model, another network also. Like just directly we can copy these weights once we are getting this thing, right? So this is the way like we can do this. This is called single layer perceptron. Now we will also have multi-layer perceptron. Single layer perceptron is a very simple concept in which we have only input and output, but this only input and output doesn't work in all the cases, right? In most of the cases, only multi-layer perceptron will work. Like we should have a hidden layer also. So for multi-layer perceptron purpose, what we have two input x1, x2, right? We are taking 0, 0, 1, 1, 0, 1, 0, 0, and we have this one. So we are talking about XOR gate, right? XOR. So in XOR means like we have false, one false, one true, then only we will get true, otherwise we will get this like false value. So this gate cannot be implemented with the help of single layer perceptron. We need to go for multi-layer perceptron. So in multi-layer perceptron means we have one hidden layer also, right? At least one hidden layer like we should have in multi-layer perceptron. So here like we have two inputs, x1 and x2, and we have one hidden layer and output. So x1 and x2 we are talking, then 0 0 we are taking, for example, the x1 x2 value 0 0, then we will assign 0 0, right? If x1 x2 value 0 1, then we'll assign 0 1, like that. And I mentioned you like we randomly assign the values of these weights. So we randomly assign this any value of these weights, right? And we calculated the output. So x1 x2 we calculated the output. So this is a hidden layer value. And this output value will be equivalent to x1 multiplied by minus 0.424 plus x2 multiplied by, like, let's say 0.358. That value will calculate. In the same way for here I will calculate whatever value we will get. We will apply activation function on that, and then after applying activation function again we will calculate the value, we get the output, right? So this is the way like we work on this multi-layer perceptrons. Now we will understand that thing in a bit detail. So like for example, we have a value of x1 is 0 0 1 1 0 1 0 1, and we have class. Now like let's start with this first value. We have x1 x2 0 0. So 0 0 we have, and these are just randomly assigned values, right, for weights. Once we are assigning this value, then we need to calculate this neuron, right? Neuron value. So how to do that? So if you are calculating this neuron value, so this neuron value will be equivalent to 0 multiplied by this particular weight plus 0 multiplied by this particular weight. So here you can understand. So once we are doing this, 0 multiplied this weight, 0, then output will be 0, right? In the same way for this neuron, some function value we need to calculate. Then like we'll have 0 multiplied with this one, 0 multiplied this one, we'll get 0. In the same way here also we'll get 0 value. So in all cases we are getting 0 value, right? Now on this 0 value we need to apply activation function. So in this case, like we are using sigmoid activation function. Sigmoid activation function I told you earlier, like this is S-shaped curve like this. Okay, so on the center we have 0.5, and on the downside 0, on the upside is 1, right? So there's a formula for sigmoid also. How we are getting the 0 to 1 value? There's a formula, y equal to y 1 over 1 plus e to the power minus x. So this x value is this one. So x equal to 0 we are going to keep here. So if we calculate this one, x equal to 0, then 1 over 1 plus x equal to 0, then e to the power 0. So e to the power 0 we are going to calculate 0, right? If you are going to calculate e to the power 0, then 1 over 1 plus e to the power 0 means 1, right? So we will get 0.5, right? 0.5 we will get, right? So in this case we will get activation value 0.5. After activation we will getting 0.5. So all have 0, so all will have 0.5 value, 0.5 value we will get, right? So this is the way like we calculate the final value using activation function. In previous example we used step activation function. In this example we are using sigmoid activation function, right? So it depends on the requirement, we can change this activation function. So now once we got this 0.5, right? So like we calculated it for 0, 0. Now same way we will calculate for next input 0, 1, right? For 0, 1 we are going to calculate, and the same way we are going to apply 0 multiply with weights will be same, right? Whatever weights we assigned randomly, this will be same, like here also like same, right? We will not change these weights, well, otherwise your calculation will not be correct. So we assigned this one, and we have 1, 1 multiplied by 0.358, right? And we are getting this one, and again we are getting this thing. Now this is the like some function value, or this function value we will pass to the activation function 1 over 1 plus e to the power minus x, right? So same 1 plus e to the power minus x. So e to the power minus, in this case, first case we are taking the x equal to 0.358. So 0.358. Just calculate this exponential value. Once you will calculate, then it will come 0.588, right? 0.588. In the same way, we can calculate here, we can calculate here, and we'll get the final output, right? And similarly, like we can calculate for 1 0, right? And similarly, we can calculate for fourth input 1 comma 1, right? So in all cases, we got a sum function, we got activation value, and we received our output. This is the way like we can work on. And then once we calculated this hidden value, right? Hidden value, then we'll work for this output neuron. So for output neuron purpose, like we got this 0.5 value. For the first one, we could receive 0.5, right? If you forget, then you can recall like 0.5, 0.5, 0.5. So now we need to take care of 0.5 only, right? Remove everything, just we need to take care of 0.5. Now the same thing we need to repeat. 0.5 multiply by this point plus 0.5 multiply by this thing with 0.5 multiply by this point, like we'll get this output, right? And this output will be passed to a sigmoid activation function again. So 1 over 1 plus e to the power minus x is minus 0.381. If we'll apply exponential and calculate this thing, then we'll get output 0.405, right? 0.405 will be the output, right? So this is the way like we can work on. So like for 0,0 we did, and same way 0,1, same way 1,0, same way 1,1 we can do this, right? So we do calculation for all these steps. This thing is called forward propagation, right? We got this thing, and we calculated error, right? Like final output we received this one 0.458, right? In this case 0.436, in this case 0.431, in this case 0.405, right? So we got this 4 outputs. So we have written like this is the actual output that was given in a table 0 1 1 0, but we got this predicted output, right, using a sigmoid activation function. So we'll calculate error, then error is this much, right? We have error. So average error we'll calculate. The average error will be the absolute error, right? So absolute error means like if it's a negative, then we'll consider it as a positive only, right? So we'll calculate the average and we get 0.499. This is called average error. So we got this error. Now this error is too much. Like 0.49 means 50% error is there. So if we have 50% error, then just to reduce this error, we need to apply backpropagation here, right? The backpropagation is similar to single layer perceptron, whatever we did earlier, but little bit there are difference because we have hidden layer also, right? So so for backpropagation purpose, what we need to do? We need to like apply the particular algorithm. Like for example, like in the input, we are initializing weights in the beginning, then we're calculating output, calculating error. Till this point, we calculated, we finished, right? Now we need to calculate new weights. So for new weights purpose, we need to apply backpropagation. And once we are getting new weights, we need to update these weights. And update weights means once we are updating and number of epochs is reached, then we need to stop. If it is not reached, then we need to calculate this output again, right? Whatever output we did till now, right? That we need to calculate again, right? So this process will be repeated so many times, and each cycle, each repetition is called one epoch, right? Like for example, we have 100 epochs, then 100 times we need to repeat this thing, right? So this is a epoch, and let's skip that part. Like just directly I'm moving to that thing. So for example, like we have these weights, we calculated all these weights, and we got error here 0 minus like 0.405, 0.405 we got error for the input 0, 0 in the previous step. So in this case, we are not applying the same formula wn plus 1 equal to wn plus input multiply with learning rate multiply by error, right? We are not applying that formula directly, but yeah, we are applying same formula, but in a different way. So how to do that? Here we are calculating error using delta in terms of delta. So delta output means for output layer we are calculating delta. So delta output will be equivalent to error multiplied by sigmoid derivative. Error multiplied by sigmoid derivative. So error is 0.405, right? Sigmoid derivative is, sigmoid derivative means like we have sigmoid 1 over 1 plus e to the power minus x, right? This is sigmoid. So derivative means the first order derivative of sigmoid function. So like for example, this is y, then first order derivative of this one. So you can easily calculate first order derivative, I know, right? But directly I can give you a formula. For example, this is called sigma, right? So if the sigma, then directly if you calculate the first order derivative, it will be equivalent to sigma 1 minus sigma, right? So you can verify this thing by calculation. Sigma multiply 1 minus sigma. This will be the first order derivative of sigmoid. So sigmoid derivative we need to calculate. So we got error this one. If you are calculating sigmoid derivative for this error term, right? So the value is 0.405, value is 0.405. So this is sigma, right? We got it from sigmoid function if you can recall, right? So this is like minus, okay, keep it minus, no problem. And then we need to calculate 1 minus 0.405. 1 minus 0.405, we need to do this. That's sigma 1 minus sigma. Okay, keep it plus only because it's an absolute value. So 0.405 plus 1 minus multiply 1 minus 0.405. We will calculate, it will come 0.241. So 0.405. Okay, let me write it correct. 0.405 multiply by 1 minus 0.405. If you calculate this thing, right, then it will come 0.241. This is called sigmoid derivative. Once we calculate sigmoid derivative, we need to calculate delta output. Delta output equal to error multiplied by sigmoid derivative. So error is 0.405, we already know, and sigmoid derivative. So this is the like delta output 0.097. Now once we calculate delta output, it's very simple. But in delta hidden, we have like little bit more step. So in delta hidden, what we have sigmoid derivative similar to previous one, but we have weight also, delta output also. Because delta hidden, for delta hidden purpose, we have weight. For delta output purpose, there is no weight after this output layer. That's why we like ignored weight in previous step, right? Here we do not use weight because we don't have weight after this output layer. So what we did, we calculated sigma derivative, weight and delta output. So same way, like delta output we already know, right? Sigmoid derivative, like this is sigmoid 0.5. Sigmoid derivative in this case, what will happen? What will be 0.5 and multiply by 1 minus sigmoid. So 1 minus 0.5, right? So this will also be 0.5. So it will be 0.25. Right, 0.25. So that's why we are getting sigmoid derivative 0.25 multiply by minus weight minus 0.017, and then we have output, right, minus 0.097, like that we are getting. So once we calculate, it's a 0. So like sigmoid delta hidden will be 0 for this layer. Then likewise we can calculate for this one, like all these things we can do similarly. We can calculate and we'll get some output, right? Once we got this, then similar kinds of formula we need to apply here. Wn plus 1 equal to Wn. Input delta learning rate. In place of error, we are writing delta here. This is the only difference with like single layer perceptor. So how we are getting delta? Delta we are calculating here, like delta hidden and delta output, like that. So just replace this error value with delta and we'll calculate the next weight, right? So this process will be repeated, and this process will be repeated, right? We will calculate delta hidden, right? And in the same way, we can apply for this delta input to for changing these weights. right? So this like one, so we have learned in this case we learned like one forward propagation from input to output and one back propagation from output to input side, right? So this cycle from input to output and output to input, this one cycle is called one epoch. One cycle is called one epoch. So this is a way like we can work on, and we can apply this backpropagation algorithm. And the target of backpropagation algorithm is to change these weights and to find the final weights. Final weights means the final weights will be the weights. On those weights, we will get the correct output. So correct output means, like for example, in this case, our outputs are 0, 1, 1, 0. Then using this backpropagation algorithm also, we are getting output 0, 1, 1, 0. Final output, we are getting 0, 1, 1, 0. Right, so weights n equal to input multiply by delta multiply by learning rate we are doing, and we are calculating all these things, right? So learning rate, you can understand at this moment, like if learning rate is high, then our weights will change drastically, right? Like for example, in this formula, if the learning rate is high, then definitely you can say like learning rate will be multiplied by this all these things, and weights will change a lot, right? If learning rate is low, then weights will change slowly. So learning rate impact, it depends on learning rate. Likewise, if delta is high, then weights will change drastically. If delta is low, weight will change slowly, like that. Okay, so this is the way we can work on. And we can have a bias also. Sometimes like it is very difficult to get correct output using input and header layer, so we add some other extra term like this, a bias, right? We add extra term bias here, right? So this bias is used to just adjust our output value, right? So but we are getting out bias, we can add and we can get the output and these things, right? So this is all about. Thank you very much for your attention, and let me know for